Good afternoon, everybody. Check my settings. Quick sound check, make sure you can all hear me. Welcome, Rachel. Welcome, Inga. Welcome, Adam. It's not quite the top of the hour. We've got about 30 people signed up, so I expect we'll get a couple more join as we tick around to the top of the hour. So I'm just going to get my slide deck up while I think of it. If you have questions and things, feel free to pop them in the chat. There'll probably be some time at the end where we can turn mics and stuff on and deal with any questions that you guys may have about how to turn them on. So I'm using this webinar for the first time today. The webinar feature in Teams. So I'm learning as I'm going here. So bear with me while I just work this out. There we go. Now you should all be able to see my screen there. See if I can come back to the chat. We've got 10 people in now. That's awesome. Joining as well. Excellent. Hi, Rachel. There's a chat in the Q&A. I'm going to ask Mark to just monitor for some of those and call my attention to any questions as they come in. Feel free to pop anything into the chat or Q&A as you wish. You can raise your hands as well. I've got 3 screens here, so I'm sharing one with the slides and what will be my SQL Server Management Studio on. And I've got you here, and I'm going to ask Mark just to keep an eye on things here as well, just to just to keep me on track. But we've ticked around to 1 minute past. We've got 12 people in. Just so everyone's aware, this is going to be recorded. It'll get posted. It won't go. I'm not going to put it live on YouTube, but I will share a link with everybody so you can come back and catch this up if you need to view it. And I'll try and set it so it doesn't expire. But this is my webinar called SQL Essentials, an introduction to writing SQL queries. For those of you that don't know me, my name is Gethin Ellis. And the reason I put this together, more and more businesses that I'm dealing with in my role as a consultant and trainer and MCT, more and more businesses are trying to make real use of their data. They're trying to treat data as an asset, right? And some people will describe data as being perhaps a bit like gold, right? A valuable asset. Now, I see it a little bit differently, if I'm being honest. I think of it a little bit more like oil. Oil, when it comes out of the ground, is next to useless. But if you go through a refining process and do something to that oil to turn it into, say, petrol, then you have a very valuable product at the end. Now, your data in its raw form is probably not as valuable as if you go through some refining process. And if you want to work with your data and get anything out of your data, the vast majority of organizations' data to date is still sat in a relational database of some kind, whether that's SQL Server, whether that's an Oracle database, whether it's MySQL. And you can use structured query language, is what SQL stands for. You can use that structured query language to work with, manipulate, and drive real value from that data. And that's what I'm going to show you today. Now, this is pitched at people who are learning SQL for the first time. If you've used it before, great, that's awesome. This is good. This is going to cover the basics. So for those people that are just getting started, they're just making their way on that journey. Right? More and more organizations are going down this data-driven path. Lots of organizations are trying to make data available to, say, citizen developers or federated development team. If you work in a large business, there might be different areas of the business looking to do different reports. So therefore, it's becoming more and more necessary for people from different backgrounds to perhaps access the data, query the database that stores that business critical data. Now, traditionally, structured query language, it might have just been a language of database developers and database administrators. But these days, it might not be DBAs and developers doing that. You might have someone you might be a data analyst, you might be working in the finance team, you might be looking at your financial data, your financial information, you might be a director of finance, you might be the managing director of a large organization with several sites, and you want to monitor the performance of each. And you might not, in that business, you might not have a DBA, you might not have a developer, so you might find you're doing this yourselves, right? So you might have you might have a hands-on CTO or head of IT who you want to get your hands dirty and query the data that's driving your reports. So there's more and more people from different roles and backgrounds with access to data because we're trying to drive real value from it, right? Now this talk is based on a series of blog posts I wrote last year called How to Write SQL Queries. So most of what you find here, the content in some way, shape or form, will be available on gettinganalyst.com on the website to refer back to. For all the sort of examples and sample scripts and the slides, they're available on my GitHub page as well, and I'll post a link out later when I send like a thank you email to show you where you can get all those. So I'll collect all those links together for you and send those out. But what I was trying to do with that is show people how they can get data out of a database, show the basics of writing SQL queries, and we're going to focus on the select statement to bring data from a SQL Server database. Now, most of what we talk about here, yes, I'm going to be using Management Studio, which is SQL Server's client interface, and I'm going to be using SQL Server Developer Edition installed on my machine here. But most of what you do could apply to any database, whether it's MySQL, whether it's Oracle, or whatever. Now, where to start? This can be a daunting thing, particularly if this is new to you and you're trying to learn, right? You want to write SQL queries, where do you start? And you might just put a quick Google in and you will find lots and lots of good resources, right? Some of the best forum or the best online resource I have found over the years is something called w3schools.com, right? They've got a variety of different languages in there. So if you're looking to tweak HTML or JSON or whatever, but the starter SQL stuff in there is really, really good. There's lots of websites, there's lots of forums like Stack Exchange that can help you answer questions. If you do have a question, feel free to post them. And there's usually various sections. So if you do feel like it's a newbie question, there's like a new section for people new. So you'll get nice answers. You won't get people sort of biting your head off. And it comes with practice. And there's lots of webinars like this. There's lots of stuff on YouTube as well. There are paid resources. There's a lot of good books. I've got a few books on the website that I talk about. And we've got a training course, not that one there. We've got a training course we are putting on at the end of February. It's a 3-day course where we're going to learn to write SQL queries from start to end, and we'll cover a lot more than we're going to cover today. If you want to come on that, I'll give a discount to everybody that's here, but I'll give you more details on that at the end. But there are other training courses out there as well. There's a Microsoft official one. There's lots of good ones. There's lots of really good books to get you started. Now, I'll give you a little bit of information about me. I've been working in the technology and data space for about 25 years now, and I've had a variety of jobs in that time, from what I would call a report writer to a web developer to a DBA. Right, and for the last 16 years, I've been running my small consulting business, gettinganalyst.com, where we do consulting and training. And a few years back, we partnered with our good friends at Widen, and we offer a variety of different services, mainly in the data space. So whether that's data platform architecture and design, whether it's getting a handle on your data strategy and aligning your data strategy to those business needs and goals that you're trying to achieve, we can help with that. So anything technical, but anything that can add value to the business, we can get involved in as well. So that might be analytics that are helping you analyze your Power BI data. It might be helping you migrate your data platforms into the cloud. It might be running performance tune-ups on your SQL databases. It might be some training. Now, my email address is here. It's getting@gettinganalyst.com. You're all more than welcome to make a note of that, and no doubt you'll get an email off me with all the links and stuff later on as well. Feel free, if you have any questions after this on anything we talk about, feel free to reach out and ask a question via email or any of the other mediums here. I think most of us are probably connected on LinkedIn in one shape or form. But if we're not, let's feel free to connect on there as well. Oh yeah, I've got a Microsoft certified trainer, and I'm an MVP too. So that's a little bit about me, right? But this story is all about this is all about somebody new learning SQL, learning structured query language for the first time and wondering where to begin. Now, I've touched on this already, right? And I'll do this by means of a demo. If you want to follow along, you want to do any of the demo scripts here, you need a couple of things. Now, I'll put the links in an email, because you can get SQL Server Developer Edition. As long as you don't use it for production and it's for learning purposes, you can use that for free. You can download SQL Server Management Studio and Azure Data Studio. All will work with SQL Server for free. Microsoft make all their databases, all their sample databases for AdventureWorks. They make those freely available as well. So these are all free to download. So my environment, I will just show you quickly while I'm here. Looks a little bit like this, right? I've got SQL Server 2022 Developer Edition installed. I've got a database called AdventureWorks LT 2019 installed on restored to the server, and I've got permission to select against it. And then through using Management Studio, I can connect to the server and I can write my queries, which is what I'm doing here. Okay, now you can get those yourself. You can bring those down yourself, and you can work with SQL Server for free. Now, as we know, right, where do you start? Well, listen, SQL is reasonably simple to master, right? But if you're going down this data-driven path and you need to use SQL, then it is becoming more and more necessary for different people to be able to query and access the database. All right. Now, writing a SQL statement is easy. I'll tell you that now. All right. What we're going to focus on today's session is using the select statement that retrieves data from your database, and that's what we're going to focus on today. Right. And every journey of I quite like the analogy of every journey of 1,000 miles starts with a single step. You have to start somewhere. All right. So what we're not going to do today, we're not going to cover like database design. We're just going to look at taking a database we already have and retrieving data from it. So structured query language is the programming language we would use for that. And writing a SQL statement is easy. Writing it well can take some practice, right? And it can be a little bit daunting, right? Especially to begin with. But once you understand the basics, you can build from there. So in this post, in this webinar, we're going to start with those fundamentals, right? And we're going to start with a database structure. Now, you can see from the screenshot here, I've got a couple of tables here. I've got a customers table, right, which is prefixed with what is called a schema. It's just a way of naming the table and grouping things together. But I've got a customer table and I've got a customer address table, and there's a relationship between them. Now, that relationship is important because what this is really telling us is every customer, right, is going to have an address. So there will be a foreign key with customer ID in the customer address table mapping these two together. So what that is saying is one-to-many relationship, one customer can have many different addresses, which might be true for your customers. Then we get into things like, right, so there are tables. These are like a basic building block. Database is going to be a model of real world things, right? In terminology, in database terminology, those real world things get called entities. So we can represent those real world things in our business, like our customers, like their addresses, like their products, in a table or an entity. Right, now those tables are going to have columns and rows. Columns are going to represent the attributes of an entity. So in this case, right, we've got a customer table, they've got a title, which is an attribute, a first name, an attribute, middle name, and so on and so forth. In addresses, an address ID, and a customer ID and a modified date in there as well. So columns represent what makes up our customer. Our customer is going to have a name, an address, and an email address. Each row represents a different instance of our customer. So for each customer, there will be a row in our table showing those together, right? So it's an instance of an entity. Okay, all right. So we need to write SQL to get data out of our database. All right, it's quite a daunting place to start. There's some tools that you can use to help do this for you. Now, things like ChatGPT and stuff actually write really good SQL. And you can use them, but I would just be a bit careful about sharing anything that might be sensitive with ChatGPT. But if you're practicing on AdventureWorks, it will actually write some good stuff for you. that actually wasn't around when I put this together, but that it can be a really useful learning aid when you're putting this together. Right, we know structured query language, or SQL, is or sometimes called SQL, is the programming language, and then we've got a table and rows, which is what we use to model our real world things that we are trying to measure. And then we get into columns, rows, and primary keys. Right, so some of the things noted here. Columns are the columns get identified by their names, not by a particular position. That's kind of important, because if you're looking at a database, it actually doesn't matter where the column sits. All right, but so columns are identified by their names. A unique column or combination of columns can be used to define a primary key. Right, it's generally good practice for all to have primary keys. Okay, so if your table has a primary key on it, the database is going to enforce uniqueness on the columns that you select as your primary key. So no other row will have the same value or values in that column. Right, so again, customer ID is a good example. Let's use an example to solidify that. Right, the single column customer ID is defined as the primary key for our customer table, and we can use that to find instances of a customer. Right, so that customer ID will uniquely identify our customer. So if I were to, when I query this in, let me just have a look here, see if I can query it. Right, so if I come here, and I'm going to do a select star, we're going in front a little bit here, we'll introduce a select, but we have a customer ID here, right? So we've got Orlando G, that is customer ID 1. If we were to try and insert another row into this table with this customer ID here, an error would be thrown because we'd be breaking referential integrity. Now, in real life, there will be relationships between our tables, right? So a customer is going to have an address, and a customer will likely have an order. So if we're modeling these entities in our database, we can model the relationships between them too, which is quite an important thing. Quite an important thing to do. Let me just get back to my slides here. So we can model those relationships. They can be done using what's called primary and foreign keys, right? So the primary key, that identifier in the parent table, so customer ID, can be a foreign key in the child table or the second table. In this case, it's address, right? Customer ID is a primary key in the customer table, and then it's a foreign key in the customer address table. So when you go to put an address in, it will check that a customer exists before it allows you to insert a row into that table, enforcing that relationship between the customer must exist. It must be a valid customer for us to use that. Now, this gets us back to the simple select statement that I was just showing, and this does work best as a demo, right? But let me just come back to this slide for a second, because we've got the layout of our select statement here, which we are going to go through, right? So what this is trying to show is the order of the different clauses, right? So we're going to work our way through some of these as we go through this session, and we'll refer back. This is quite a good slide to use. You can refer back to it as you go on your SQL journey. You'll find this in quite a lot of documentation on Microsoft sites and other SQL sites as well. But the select clause is always needed with at least one expression. So it doesn't have to be a table. I don't want to confuse things. Normally it would be select, then you would list your columns from a table. All right. We'll look at each of these clauses, but the where is a filter condition. So that allows us to filter out rows. Group by can be good for doing aggregations on groups. So let's just say we wanted to do a sum of all sales per customer. We could group by customer and then sum sales by that customer. Having allows us to filter on aggregates, and the order by clause down here at the bottom will allow us to specify the sort order of the results. All right, so if I come and run this here, the star in here, the asterisks or the star, means we want to select all the rows from a table. Generally, if you were writing this for production code for an application, you wouldn't want a star in there, because if the table changes, the columns you retrieve can change. So you might want to be specific on the columns that you pick, and only pick the columns that you need. Now, taking this back, right, I showed you I'd installed SQL Server, I've connected to it, and I've restored the AdventureWorks database here. You will see all the different tables that are available in here, customer address, product category, and so on. If I hit the new query window button at the top of the screen, it will give me a new page. And what I'm going to do now, I'm just going to do Control-A, Control-C, and I'm going to paste that in here just to show you what I've got, what's available in here. This use statement, right? This is quite important because it will mean the code will execute in the right context of it'll execute in the right database. So if I run this as it stands, right, and I'm selecting first name and last name from customer, it throws me an error because the context here is the master database, which is the default. So this use statement will mean I'm always executing in the right database. You can see there, having run it and highlighting and then clicking execute will run the code for you, changes the database we are running in. Come down to select first name, last name from customer. It gives us a list of 847 rows returned and showing the first and last name of each customer. Would help if I could get that right, wouldn't it? There we go. Still can't do it. There we go. Control Z, get rid of them. Gives us a list of our customers there. Okay, now select star selects all the columns. So I've been specific here and chosen I've chosen the column names. If I choose select star, you can see it gives me every row. Right, and with 847 rows, this isn't much of an issue. But if this row's got millions and millions and millions of rows in there, which some of your databases I suspect will have, selecting all that uses more resources. More resources leads to bad performance. Right, so you end up with retrieving more data than you need. Your database server does more work than it needs to, and that can impact across the board. Okay, so then we have. I'm going to end the slideshow here, and I'm going to go on to. I'm just going to go to the demo slide, but just bear with me. That's my clicker. Right, we'll do some of this now as a demo. Now, there are slides in here, right? Because we've kind of got columns and expressions, right? That's what I want to talk about, columns and expressions next. When in a select statement, you can have select from a table, you're going to list your columns. They are called column expressions because you can change them a little bit. Now, in this example, right, you will see if I do select, it brings back the relative columns, and right at the top, it gives me column names, first name and last name, which are taken from the column names themselves. Okay. Now, if I scroll down a little bit, it might be that we don't want. All right. We might do something to a column name. So in this example, right, I've added in middle name, but I'm using a substring function. So I'm selecting first name and last name. I'm returning middle name. So I'm trying to bring the initial back where they have it. So if I run this and click on execute, you will see there is a third column returned, right? And all the columns in your list are separated by commas. Right, so it's first name, comma, substring. Because we're doing something else to this column, it doesn't take the column name. It comes in as no column name, which can be quite unhelpful for your results. But you can use what is called an alias. Right, so you write your column expression, which in this case is taking the first letter of the middle name column, and I'm going to name it initial. So now when I run this using this alias, you can see the column header, the column name is now initial, and it's taken it from my code there because I've used an alias to define it. Now I could do the same with first name if I wanted to present this a bit differently. So I wanted to call it as F name. The as is optional, right? So it would take it without the as, but I would always recommend you leave it in, and you can see that I've renamed that as F name. So you can override the column names being returned if you want to. And where I was going with the as being optional, right? If you look at this, I'm missing a comma, so SQL doesn't know, and I've not put an as in. If I were to highlight this and run it, it'll give me one column returned with all the first names under the alias of last name. Right, so that's an accidental alias because it's taken that there. So that's code that's run. It hasn't errored, but it's not the results that I was expecting from this code. So that's just something to be aware of. Those commas are important. All right, and if you did want to use an alias, use as, because then it's absolutely clear what you were trying to do. All right, as alias, put a comma in there. That should be good, and then we can run it. All right, it gives us our results back, and we've got a column named alias. Now, That's retrieve data from a single table. Could be a customer table, could be an accounts table, could be an orders table. Call it what you like. Now, it might be you want to filter. You don't want all the rows returned. You just want the ones that relate to a particular customer. And this is where the where clause comes into play. All right, so we've got a select statement here. We've got customer ID. I put customer ID in there just to show you that they are in fact customer ID 19 and that this is in fact working. But this where clause, if I execute here, runs, and it just brings me one row back. Customer ID is a primary key. There will only be one value of, if it exists, there will only be one value of 19 in there, so we get one row back, and we filtered out the other rows. Now, that's done on an equal sign, so we're saying where customer ID equals 19, give us all those rows. Right, we can combine these filters together, these where clauses together. So in this example, I'm saying where customer ID is greater than or equal to 19, and customer ID is greater, is less than 23. So if I run that select statement, it then gives us the customer IDs that fall into that range. We can do the same with dates. So this is on numeric data types. Each of the columns will have a specific data type. So it's the type of data that's stored in that column, and how you address those in your where clause differ. So this is a modified date is a date. Right, it's a date data type, and you have to pass it in as a string. So you have to have these single quotes around your date. But in this example, we are looking for all rows where the modified date falls between the 1st of September 2007 and the 30th of September 2007. So if I run that, it gives us those results. 94 rows back, it shows you the modified date and time in there. So we've done a range search. In the where clause can work with like. So if you want to do, it's kind of like a fuzzy search. It's not quite as good at that. But this example here, right, if we wanted to return all our customers where last name begins with the letter A, then we can use the like statement. Then we can use the wildcard. Now the wildcard in this case is the percentage sign. Excuse me, right? So this is going to say, right, I want everything that starts with an A in last name. Give me those results. And we can see there we get all the A's, all 46 of them, down to Mary Alexander, whose last name is in there, right? Now, by default, the order is unimportant in a relational database. You can only guarantee the order of your results if you use an order by clause, right? So if I run this here, click on execute, right, we've got different dates. I think they all fall on like the, yes, it's looking at across a couple of months, right? You can see there that they're not in modified date order. They're probably in customer ID order, because that's how they optimize it. Would have gone away and looked and retrieved it. Oh, it's in that order. Let me pull that back. But if I wanted it to be ordered on modified date, so I have the earliest first. Now, we change our queries. We have our select statement. We specify from. Right, and we've got our list of columns. We've got our where clause, which is specifying the date range, and that's giving us our results. But we now want to change the order, so we're going to order by modified date. Now, there's another parameter I can pass in here. You can do ascending or you can do descending. Right, now, it will default to ascending. So if you just get order by, it's going to put it earliest first. So if this was a numeric column, it start at 1 and work backwards. If you go descending, it'll start with the highest number. With dates, it's early to late. Right, so if I do this, and I just highlight and run my select statement, we get 197 rows returned. The 1st of June 2007 is the first record modified date, and if we come all the way down, we can see we're going through August and September down to Pamela here, where it's in September itself. And you can see there that does mean that the customer ID is not now ordered by customer ID, right? But to guarantee the order, you need to use order by anyway. Now, it might be you want to have the records that were modified more recently, right? So using this same example now, I can add descending to my list, and that'll order them the other way around. So instead of having it going from June to September, we'll go from September to June. Right, so we've got all the dates in September, then it'll drop to August, and then it'll come back to July, and then we've got June at the end. You can sort on more than one column. So in this case, I'm ordering by, it's the same query, exactly the same filter, exactly the same results, ordering by modified date descending. So we're putting it in the latest modified first, and then we're ordering by last name. Right, so we'll put them all in order where the dates match, and then they'll order them by last name. So you can see there we got the 1st of September, and then we've got a last name A, and it comes down to B's. Right, and then when that modified date changes, which it will do any second, there we go, we come back to A's again, and they're in last name order. So you can specify the sort order of your results. Right, so next I'm going to talk about nulls. All right, and nulls are quite important because depending on how your database is designed, they may contain unknown values. Right, so when you specify that, when a database designer specifies the columns in a table, they can specify whether it has to have a value or whether that value is optional. Right, which does make it quite interesting. And there's some nuances with these unknown values, which are referred to as null values, and how you deal with them in your code. But for a fundamentals class, you want to be able to deal with nulls because they can affect your aggregations. So if you are looking to do analytics on your sales, you want to make sure you're dealing with nulls in the right way. But just look at this here. Select from our product table, right? So we're getting our products back. You can see that the size and weight are unknown for some of these products. Now, if I come down, right, and I'm doing a calculation. I'm going to divide standard cost, which has a value, by weight to give me the cost to weight ratio. Why you'd want to do this is I haven't actually found out the reason why you might want to do this division, but it serves a purpose for me showing you what happens when you do a divide by null. Where there is a weight and a cost, the cost to weight ratio can be calculated, as you will see here. All right, so we have got a weight value and we have got a standard cost value. Then we come down a bit, right? We have a standard cost, so it's 13.00. We're dividing that by an unknown value, therefore the result is unknown. Right, so it's important that you realize that can impact on your calculations if there is a null column in the mix. All right, and how nulls are dealt with. Now, there's a couple of functions we can use to deal with this null value, right? And in SQL Server, there's a function called isNull, but as part of the standard, the function is collase, right? And this will deal with null values. So what collase will do, it'll take the first non-null expression. So in this example here, I'm running my select, right? And I've got weight, and then I'm creating another column expression that I'm going to call collase weight, right? And I'm going to pass in the weight column. So where the weight column actually has a value, it'll return it. If it's null, though, it'll return 1. Well, and then for my standard cost to weight ratio, I'm taking standard cost, which doesn't, you have to put a cost in when you're entering data, and I'm dividing that, and I'm using that same expression to do the division. So I'm no longer dividing by an unknown value. And this should give me results across the board. All right, so you can see there now, we now get a cost to weight, a cost to weight ratio where the standard cost and the weight have a value. And we also get it where the standard cost has a known value, but the weight is unknown. We are doing that division by 1 to give us the answer that we want. Now you can deal with those however best suits. All right, but that's what those collase functions can do for you. So we'll use the same example, right? This is an interesting example. So what I'm querying here now, nulls can affect your filter conditions as well. So it's quite important to look at those. We've got to select product ID, right? Listing our columns. We're doing our collase on the column expressions, and we are saying where weight equals null. Now, some of you might expect this to return results. However, when I execute it, it brings back nothing. Because a null is unknown, it therefore can't equal anything. It's not the text string null, it's an unknown value. So if you want to filter your null values, you can't use the regular sort of expressions of equals and greater than and all those types of that you might put in. We would have to use this. And it's an isNull function. So what this particular query is going to do It's the same query, but instead of saying where weight equals null, we're going to say where weight is unknown. That's the best way to think of it. Where the weight is unknown, give us those rows. All right, and this now then, we've done the case, so we can see the weight is unknown here. We've got all the divisions and stuff are returning rows for us, but all the weights in here, all 97 unknown weights are being returned. Okay, so we've gone through all that pretty quickly, all right? We've gone through the order, we've gone through all the clauses in there except one, the join, all right? And this, if you as you start to write your SQL queries, it's very likely you're going to want to write some joins. You're going to want to get data from more than one table, right? Now, there are a couple of different types of joins, and I am going to revert to the slides here just to make sure I give you all the information that you need. Now, that's not where I wanted to go. I'm a bit further on than that. I'm going to come down to inner joins, right? And this is actually quite a good way of showing it. A join is how we retrieve data from from multiple tables. Now, this is often, when people are new to SQL, perhaps the most difficult bit to get your head around. When you learn it for the first time, it can take a while, but once you've got it, it'll stick with you. Once you've mastered it, you're probably always going to write queries with joins in. Right, because our tables are related. So in this case, we've got customer, we've got address, we've got order details sat on there. We're going to want to, if we want to get orders for a particular customer, we need to get data from both tables. And this is where I will refer back. So the default behavior in structured query language is for a join to default to an inner join, and this will look for matches. And the easiest way for me to do that is to show you. So I've got a select statement here. Right, I'm selecting customer data, where I've got customer ID is this particular customer ID here, coming from the customers table. Click on execute. There's Mr. David Hodgkinson. Right, and then I'm going to do a select from our sales order header table, where the customer ID in that table matches Mr. David Hodgkinson's here. All right, so I run these as two separate queries. All right, so I've got it sales order ID, customer order, and total due. I can run those together. Right, and we get two different result sets. Now, if I wanted to join these together, right, so we've got our select here. I'll come down and show you the join first. Ignore the columns for a minute. I'll come back and explain those in just a second. Right, but we've got our from customer table. Right, so we're going to get our customer first name and last name. Inner join sales order header, where we're going to retain sales order ID, customer ID, and total due. Right, and then we're going to map on the column. Now, in this case, it's a primary foreign key relationship. So it's the customer ID in the customer table is going to match the customer ID in the sales order header. So where there's a match, we will get rows returned. And in this case, we can still have our where clause. So if I just take this down a bit so you can see it. All right, so we've got our select. We've got our inner join, so it's going to return all matches. Click on execute, and we get Mr. David Hodgson back, and we've merged his order details into that result set for us. And that's the magic of the join and this join condition here. Now, when I was explaining this, I touched on aliases earlier on. When you're writing a join, aliases come into their own in providing what Mark would call clarity, allowing people to easily see what it is you're intending. Right, so we looked at column aliases. We can give our table an alias as well. So if I look at this query here, it's the exact same query, but just written with aliases. Right, so you can see sales LT customer has now got an alias of C, and the sales order header has got an alias of S. In the select list, we specify when you write a join, it's good practice to reference the columns to make sure, because different tables can have the same column name, so we want to make sure we get it from the right table. So in this case, we're getting customer ID, title, first name and last name from the customers table, and we're getting sales order ID, customer ID, and total due from the sales order header. We have classified those as alias them as CNS respectively in the join, and then where we are using those aliases everywhere else in the query, we need to use those aliases. It'll give us an error. Whereas in the one above, we were using the fully qualified table name and schema name, and it got very cumbersome quite quickly. I think perhaps it's just me. This seems much easier to read than this one here and understand where things are coming from. So alias is quite important when we are working with joins. Now, outer joins. That has just looked for matches where there's a match on customer ID in both tables. If there's a match, we get a result back. Now, outer joins can help us set a precedence for the table. So this example here, we're doing a left outer join, right? Now, the easiest way to think of this, if I delete this up here, right, if I move this across, just to see if I get it all onto one line, right? That's the easiest way to do it. So left outer join, what we're saying here, the table to the left of this statement is the driving table. It is the most important table, right? This one here. So we're going to get all our customers back, right? And where there's a match in the order header table, bring that data in. Otherwise, it's going to return a null value. So this will give us all our customers, regardless of where they have, whether or not they have an order or not. Because in the last example, if they haven't got an order, they would be excluded from the list. And we've got a where clause here. We're saying where the sales order ID is unknown. All right, so we're going to just look for customers who don't have orders. All right, so that can help us find those customers. Whether you can have a customer that doesn't have an order remains to be seen, but you can see there are several, actually most of our customers in here don't have an order with us. So it gives us that list, and then we can go and set our salespeople on giving them a ring and finding out why. Now, the reverse of that is the right outer join, and all that does is change the order of preference. And what I mean by that is, whereas in the left outer join up here, the first table listed was customer is the driving table, we've changed it to right outer join, right? So we're going to say the sales order header. Now, I can't remember if this actually works. I can't imagine you could have an order without a customer, but let's see if our data allows it. And it doesn't, right? Because it doesn't make sense. Right, you wouldn't have an order without a customer, so that's ideal. But if you did have a sort of data quality issue that was showing that, then it would pull that out for you. Now I wrote right outer join here. The other just one thing to remember is it's just the order in which the tables are listed. So I could have written this same query where I said the order header table was the driving table, right? The preferred table. We want all rows from that by listing it first and writing a left outer join. And I find it easier to do that when I'm writing my SQL queries because joins are still a little bit confusing. If I just stick to left, I know exactly how the behavior works. And then I think this is my last example. I'm sure you'll all be delighted. This is a full outer join. So this is going to get data from both tables. Where there's a match, it'll bring them, but it'll give us all our customers and all our sales orders as well, and that'll give us rows. And then if I scroll down through, we will see where there's orders: Corey, Walter, Brian. Their details are returned, but where they don't have an order, they are included as well. Okay, right. So that was outer joins. I've got the slide deck available. I think sometimes it's better done by way of a demo. That is pretty much all I wanted to talk about and show you by means of a demo. I'll make the scripts available to you. We're running a training course at the end of February. The dates are wrong on there. How I missed that, I don't know, but the dates are wrong on there. They're running from the 26th of February. We've got a 3-day training course where we will learn structured query language together, right? It's learn to master Transact-SQL. We're selling it at 1,800 £1,800 plus VAT for the 3 days. But because you've come on this webinar, and because I'm a nice guy, right, I will give everyone who's attended here today, we're going to give everyone a discount, right? So if you order off the website, you use promo code 550. But if you just email me if you're interested, you could, or fill the booking form in on the course, we'll get in touch and we'll give you that discount as well. And if you've got colleagues and stuff that might want to come along, have a chat with us and we'll see if we can work out some discounts for you as well. The QR code will take you to our booking form, so if you want to scan that, please feel free. And otherwise, guys, I will open up that floor. Thank you all for coming. I'll open up the floor for questions if you have any. And yeah, thank you for coming. Thanks, Sue. Brilliant. I've enabled all your mics, so if anyone does have a question, feel free to shout out. Cheers, Adam. Thanks, mate. Take it easy. Cheers, Bethany. No problem, Sue.
I guess then, just a question.
Yes, George.
Was there a reason why you used the curly braces around a column name on one of your queries, or was it
Let me show you. There can be a valid reason. You can still see my screen there, yeah?
Yeah.
Which one was? So you can do that by curly braces. Do you remember which one it was?
No.
These ones here. These ones, is that what you're talking about? Right. If someone designs a database, right, you have your permission. If anyone does this to you, you have permission to shout at them. They can put spaces in column names. Now,
I see.
Most people would not do that now. But if there's a space in the name, you have to enclose them in those square brackets. And if you do, one of the easiest ways to write a query would be to say, let's say I wanted customer data. If I come down and right-click customer, go to select top 100 rows, all right? Because it's not clever enough to work out if it needs the square brackets or not. It just puts them on for all of them.
Mm-hmm.
And it's just a way of allowing for spaces and other things in the George. So that's the reason for it. But these would all work without.
Yeah.
It would work without them. So there's no reason for doing it, but sometimes you need to do it if you're working with spaces, is the short answer.
Okay, brilliant.
Cool.
All right, I appreciate it again.
Cheers, George. Take it easy, mate. See you later.
Bye.
All right, then. If there's no other questions, guys, I'm going to take this as a chance to shut this down. Thank you all for coming, and I'll see you again.
Do you want to catch up in a bit on the other teams or something, or wherever?